Good afternoon, everyone. Welcome to our webinar, Guidance on Construction of SuDS and Introduction to Serious New Publication, C768. I think webinars today are the perfect way of holding the meeting with the weather and people suffering from lurgy. And despite all that, our two speakers have actually managed to make it in here to Syria today. And we have over 200 people signed up, so we're extremely grateful. And thank you to Sue and to Steve for coming in. I'm Suzanne Simmons, and I'm from Syria. I'm the project manager for the delivery of this project and a number of other SuDS-related material here at Syria. Our presenters today are the author team for the delivery of this project. That's Sue Illman and Steve Wilson. Sue Illman is also a landscape architect, managing director of Illman Young and past president of the Landscape Institute. Sue is well known for her advocacy work promoting integrated water management and SuDS, catchment management, and the integration of grey, green, and blue through interprofessional collaboration. In addition to her current role, Sue is a champion for flood mitigation and resilience on behalf of the Construction Industry Council, the CIC, and Sue was also one of the authors of the SuDS manual. Steve Wilson from EPG is a chartered engineer with over 30 years' experience of geotechnical and environmental engineering. He has designed and supervised the construction of many types of SuDS, as well as acting as an expert witness. His main areas of interest are pervious surfaces, green-blue roofs, geocellular tanks, and the interface between engineering and landscape design. He also is an author of the SuDS manual. So the presentation today is a summary of nearly 2 years of work, and the driver behind the guidance is that good SuDS design can be misinterpreted and often let down by poor construction and detailing. This can affect performance and ultimately cause failure. So with SuDS becoming more commonplace and the diversity of schemes and applications growing, it's now timely for this project to release up-to-date guidance on SuDS construction to ensure that they're built as designed and to provide performance and benefits required. So, a few notes before I hand over to the author team. You are all on silent, so you can hear only myself and the presenters at the moment. We will reserve any questions you have until the end of both of the presentations, because there's so many of you logged on, it would be pretty impossible to go through every question as it arises. You can also type in your query, and if we get a chance, we may well read it out and the team will try and answer it. If not, we'll be able to answer queries at the end of the presentation, post-presentation, and circulate them to attendees. So if we run over time with question answers, do make sure you do type in your question. Please note also that this webinar is being recorded and it will be posted on the Syria website and sustrain.org to share with colleagues for future reference. So now I'm going to hand over to our presenters who will take you through for the rest of the webinar. Thank you very much. I'll just put you on hold for 2 seconds while we position ourselves.
Afternoon, everyone. Sue here. What we're going to do is to run through the rationale for the guidance and its general contents, and then focus on some of the key issues that arose as we were developing the guidance, just to emphasise some of the more important areas, in the hope that you'll get a broad understanding of what the document contains, and then be able to dip into it as you need to actually find what you want in any circumstance, or indeed to just give guidance to how the construction side of a project may need to be run. So really just to say in the first instance that what we're seeing now is that SuDS really are happening everywhere. Recent research has shown that an element of SuDS is actually occurring in about 80% of all planning applications. So we are really seeing an awful lot of it. And of course, there's an awful lot of extensions, redevelopment and retrofitting happening as well. So this is very much of the moment. Just putting out our technology here. Okay. So really just to say that the potential for SuDS is everywhere. Hopefully you've all seen the SuDS manual and understand the scope of the components that you can use. These ones are the ones that we're going to use most commonly within landscape and urban design. But of course, there's also the hard SuDS as well, with the rainwater harvesting and the various below ground systems that we need. So the comprehensive range of SuDS is really what's addressed in the construction guidance. And of course, they come in all shapes and sizes and the scale of what we're doing, that we need to be able to adapt how we design and how we construct to actually work for any size of scheme anywhere. And that generates, of necessity, some of the problems that arise in construction. So when we started this project, first of all, we really wanted to understand, by sending a questionnaire out to the industry, what were the problems that were generally arising in building SuDS, and therefore what did we need to write to actually help solve those problems. And that message came back loud and clear in terms of where that people saw the main problems lying. And those were perhaps inevitably about level changes happening on site that had perhaps not been anticipated. The fact that when the concept scheme was designed, cut and fill across the site hadn't been properly addressed. And particularly when you're looking at retrofitting, conflicts with services really arose on most projects. At the same time, there was a range of problems that commonly arose as well. And those were inadequacies in the design drawings that really had not addressed the whole of the design comprehensively, the nature of existing site information that hadn't been recorded properly and should have informed the SuDS design process, giving circumstances that then needed to be addressed during construction. The fact that throughout the contract, additional hard surfaces may be required, which then required additional design details to enable them to be integrated within the scheme, where changes of materials occurred that could have an impact on the way that the scheme actually functioned, or indeed changes on site or poor construction, and sometimes changes, inadvertent ones, where really the impact on the SuDS scheme was not considered. And then quite often the fact that these days many more contractors are now building SuDS, and all of them are inexperienced when they start doing their SuDS construction, and that there's a very steep learning curve for those contractors to really get to grips with the problems that could arise on site. Other problems that we asked about, and it was interesting that conflicts with areas of ecological importance or with tree root protection zones really didn't seem to be that much of a problem. I think because generally people have to address those during construction on any site, so there was no particular concern over that when building SuDS. But in summary, really, generally, the issues that arose were very much around the visual quality, the physical construction, and then the functionality of the scheme to make sure that it would work properly on the ground.
Hi, so it's Steve here now. So some of the other issues that arose were constructing SuDS on difficult sites, which is also picked up in the SuDS manual in terms of design for these conditions as well. So issues that can cause construction problems on site are groundwater and the presence of SuDS in groundwater source protection areas, unstable fill materials, contaminated land and the impact and how you address construction in those conditions, constructing SuDS on steep slopes, and the converse of that, constructing SuDS on flat sites.
So that really brings us to what the contents of the overall document is. So it looks fairly lengthy, but as you will see if you've dipped into it, each of these chapters are really quite small, because when we were developing the system, the whole point about this was to make it very simple, very straightforward, and to be written in simple English that anybody could understand, and to make it as accessible to people as possible. And from that point of view, one of the things that you'll find in every chapter is a thing called a jargon buster. And that is to explain any technical language that we really couldn't avoid using, and we really have tried to make it an absolute minimum, so that you can pick up the book, open it at any point, and hopefully understand what's written, because any jargon that happens in that chapter will be fully explained to you in a simpler way as possible. We've also included, because this was compiled with a lot of help from industry as a whole, these series of things called handy hints, watch points and hold points. And this is where people have shared their knowledge and experience with us in building SuDS. And so what we've done is to try and identify these things for you to again assist you in your journey in learning how to do SuDS construction. So a handy hint is something that we've learnt along the way that is hopefully a helpful tip that may apply to your project and worth considering. A watch point is obviously something that really you just need to be aware of, because a problem could arise. And so just watch out to see what the implications of it are and consider that in your project. And then hold points, perhaps a bit more of a stronger point here. This is something that you really need to wait for, to inspect the works and check before moving to the next stage. So again, you can see the graphic approach that we've taken to try and make it, perhaps a little bit fun, but also to have a serious purpose of communicating the issues that can arise on site. As part of that, with the work that we did with the project steering group in developing the guidance, is we actually took a lot of case studies from people. And these are two different sorts. They're mini case studies, which are throughout the document, which just deals with a very specific issue that happened on a particular site. And then at the end, there are major case studies at the end. There's just 5 of those that look at the scheme comprehensively and the issues that arose. And the important thing with these case studies is to understand what the challenges were that arose, and then what the outcome was and what was learned. And I do like this one example. So what you're looking at here is some granite sets that have been installed, where the contractor inadvertently misunderstood, and this is his interpretation of an outfall, which was supposed to be a gabion filled with stone that would allow water to filter through. And clearly, as you can see, that not much water would filter through that. So again, a very willing contractor doing his best, completely misunderstanding, and therefore the need to change that. And this is perhaps not atypical of some of the problems that can arise on site. And so this is really just to point out perhaps that what we're doing here in construction is hopefully, in terms of working with the SuDS principles, trying to deliver some equality between quality, quantity, amenity and biodiversity. But the point of the SuDS construction is that if we don't construct it properly, then we're going to cause ourselves many problems in actually trying to deliver those SuDS principles, because so much of what we're wanting to do is based around maintaining the soil structure, maintaining its infiltration capacity, and then preventing damage to the site through compaction, erosion and pollution, and the silts or sediments that would arise during a construction contract. And the need to understand that there is such a difficulty in reinstating damaged soils, as well as the need to actually maintain existing vegetation and ecology. Okay, so then really, what's different about building SuDS and how do we get it right? And you'll notice in the document what we're talking about a lot of the time is how to get it right and to prevent things going wrong. And so this is really just a summary of how the document works. So it's about being properly prepared before starting. That's both in terms of the site and the scheme. Planning the works to make sure you can get it right. Planning to avoid the potential site problems that are likely to arise or frequently arise on site. And then how we manage the site and the works themselves during construction. And then at the end, we'll look at the typical challenges that arise for a few of the specific SuDS components. So just starting with the first chapter really is just an introduction, talking about what are SuDS and what makes SuDS different, and really stressing the difference between traditional systems and SuDS systems, and the need for care in construction, and why SuDS actually can affect the construction planning process.
So in these initial sections, the pre-construction section, what we're looking at is the baseline information that a contractor needs to be provided with, how the contractor needs to understand the design requirements, because a lot of problems that have occurred really occur as a result of a lack of understanding of what's been or what the SuDS are trying to achieve, and then specific site considerations and a pre-construction checklist. So pre-construction, being properly prepared, so the baseline information about the site, and then understand the scheme requirements. So on the right hand side, you can see here that there's a very simple diagram, and it's the word diagram that's important there. It's not an engineering drawing, it's a diagram to explain to the contractor how the system is going to work. And it should be easy to understand. The contractor, even down to a foreman on site, should be able to pick that diagram up and be able to understand it easily. So it's checking how the design works, and also the specific specification requirements, because quite often we're using materials that may have the same name as normal materials, for example a sub-base in a permeable pavement, but the properties and specification requirements are different to what would be normally required. They're also on and off-site considerations, so you need to understand the impact of construction off-site, and at the end of this section there's a checklist that's there for contractors to use. But also it's there in a form that you can adapt it to your own specific requirements. So construction planning and programming. There's in Chapter 7 there's a description of the site team. Chapter 8, factors influencing the phasing of SuDS construction works. Getting the right materials for the job, which I've said already is really important. And then again, there's a checklist at the end of it. So, construction planning and programming, this is the key. It's the key to any construction, good construction. It's not just SuDS. This applies to anything. So people should be familiar with a lot of this process. So there's the site team and how they behave. And we can see here that there's a table in there that shows the site team, and it just explains some of the differences between their input into traditional drainage construction and what their input, how it might change in when you're constructing SuDS. So if we look at the site designer, for normal drainage, you can see at the top left-hand side there that the design is employed after the site layout is determined, but has little input into the design, whereas their role will be different from SuDS. And although this is not specifically a construction issue, it does have an impact on constructability. That for SuDS they need to be involved. The drainage designer, the SuDS designer, really needs to be involved in the process of the development layout from the start. Because it does make it easier to construct the SuDS that have been designed. You do have to think about the phasing and some of the issues that site managers have to deal with that will impact on how the SuDS is used during construction, and how the phasing of the SuDS construction can be influenced by other factors that are nothing to do, that are outside the SuDS design in effect. So this example that we've put in here was a site I was working on for the remediation of a contaminated site. And I realised that it got quite a lot of SuDS in the open space. So I sat down with the site manager and we went through some of the things that he'd got to think about that impacted on the construction of the SuDS. So for example, the first thing that the housing developer wants to build is the show homes. They want to complete those first. So you can see area 1, that's the first area. But if you had an ideal SuDS design, that area would drain towards the bottom of the page, towards the open space that is going to be integrated further down the site. But that wasn't available when they were building the show homes. And similarly for area 2, the grey area underneath area 2 is a big public open space where there will be SuDS in the completed scheme, which you can see in the third diagram on the top right of that slide. But at the time of construction of area 2, the POS, because of site constraints, was being used as the site car park and as the compound for materials storage. So they actually had to build a temporary basin and pipe it to a basin that did become part of the final SuDS design, although it was only part of the final SuDS design. And then, because they were using it for drainage during construction, obviously it will build up a lot of silt. So after that, at the end of the construction period, they had to go back and clean it out and rehabilitate it and put the final landscaping in. Another issue which you can see on the bottom left-hand diagram is with housing association units that are designated. The housing association is going to basically own those units. But it's quite common that they won't accept ownership until the streetscape is fully completed. And so if you've got housing association plots alongside some of the main access routes into the site, you can't use permeable pavement in those areas, because obviously if the housing association wants it completed up to the top of the surfacing, they will get clogged when other phases are being constructed. So there are other things on there that are explained, but that is, as I said, it's from an actual site and a discussion with the site manager. So again, that's factors to be considered when you're looking at variations or substituting products. This is quite important either in permeable pavements where you've got geomembranes or geocellular units, plastic tanks, because they all have different properties, and it's important to understand if you are changing from specified products, it shouldn't influence the design performance of the SuDS. So if there are any substitutions of products, the contractor needs to refer back to the designer to make sure that the performance is not going to be affected.
Okay, so we're going to now look at site management. So that's very much talking about managing the soils on site, SuDS and the site access, the issues around erosion and silt, and again, and on establishing planting. So managing the site, so avoiding what can go wrong. As I said, this is very much the approach that we're talking about, getting it right to avoid what can go wrong. So as I say, managing soils, SuDS and site access, erosion and silt, and establishing planting. So this first one is really just showing you how in the document it is laid out, and you'll see that we're using this green thumbs up, getting it right, and red thumbs down, what can go wrong. And in that, we're illustrating that with images of as many as possible of things going wrong. And if we couldn't find those, then examples of good practice of how to do things to make sure they go right. So this is really the approach that's been taken throughout the document, and these are all live examples taken from industry to actually show what happens on sites, which I hope gives you a really good steer on what the problems are and the scale of what can happen there.
So one of the main issues that we come across quite commonly is using permeable pavements and the need to use roads as a construction access. So obviously the open graded aggregate that we use as a sub-base in the permeable pavements is easily clogged by mud and debris from construction traffic, but it is normal to construct the sub-base for roads and then use it as the site access. And there are various ways that we've seen used on site to address this issue so that the sub-base can be used as the access. So, for example, on the top left-hand side, a very, very common approach is to lay the sub-base and then put a layer of impermeable asphalt, or DBN, over the top of it and use that as the construction access. And then at the end of construction, the very last operation is to clean that off so that you've got nice clean asphalt, core through it. I think normally it's a metre centres, 75mm diameter holes, fill those with free draining gravel, and then construct the block paving surface, the permeable block paving on top of it. But there are other, people use sacrificial layers of type 1 sub-base that are separated from the main sub-base by a geotextile, and then strip that off at the end, and that's shown there. And there are other examples shown within the document of how you can manage that issue.
Okay, and then managing silt and erosion. Clearly this is one of the problems that occurs very frequently on sites, and this is very much also part of the planning process to consider what you're doing, how you know these things are going to arise, that you are going to have silt and erosion problems on site, and sometimes actually doing the excavations for things like swales is a very effective way of managing those problems on site. The key being to understand that in due course those will all need to be fully remediated before they can actually be constructed in their proper final form. And some of the problems that we see is where things like swales are actually constructed and finished and then allowed to be used, or inadvertently indeed, collecting silts and sediments, and then that's when the problems of remediation really occurs. And also about thinking in terms of the planning, times of year, the fact that if you need your ground to be established in terms of grass cover to prevent the runoff from water, then to have anticipated that you really can't sow grass seed in the middle of winter and think that it will grow sufficiently to be effective. So again, planning your works to manage a problem that you know will happen, and it may be that you have to turf some of these areas to enable you to get that management. But having that very active view of understanding what will arise and planning around that is really very fundamental to actually getting it right. And then establishing planting, really understanding why you should plant early and what plants and grass contribute. And that is mainly to do with the fact that prevention of silt and erosion, and the fact that if you want to put water into a system, you have to have your planting or your grass well established before you can allow water to run through it. So that means you do need to consider the time of year, or if, when you get there, you've say dug your swale and you need to be able to put water into it quite quickly and you can't wait for the grass seed to establish, then the tip is always to turf the base and partially up the sides of your swale so that you can enable it to root down much more quickly, and you can pin that down so that it's not eroded by water. And what will happen if you were looking for a wildflower meadow grass along the sides of it, it doesn't particularly matter if you have turfed the bottom and partially up the sides, because if you seed the upper part of your swale, in due course you will get colonisation into the base of the swale on the basis that the plants themselves were established in the environment that suits them best. So the fact that you might not have got exactly what you wanted day one doesn't mean to say that that won't develop over time. Then why plants die? That really is about understanding, and it should have been addressed through the design stage, the fact that it's about right plants in the right places. And the big mistake that people make is thinking that in things like bioretention planters, that you want wetland plants, which you don't. Clearly, you do want plants that are tolerant in ponds and wetlands of the damp conditions. But when you're looking at things like bioretention planters, that actually is a system because of the nature of the substrate, which is free draining. And therefore, what you're looking for is plants that are tolerant of either drought conditions or just ordinary conditions, in fact, so ordinary plants. And therefore, when you're looking at substitutions, you need to ensure that if there's any changes, that actually you're considering the actual conditions that are going to arise in the scheme. And then also understanding, the different stages in the planting, and that's very much about making sure you get the ground preparations right and the right constituent mixes for the type of studs to enable the plants there to do their job. And their job is very much not only about holding the soil together, but improving the quality of the water runoff. And so we need them to be well rooted down and growing for that. To get them growing strongly, and then to ensure that they develop and are managed at the size that they need to be to continue to do that job throughout the life of the scheme.
So, Section E is about constructing and inspecting SuDS, and you can see there the list of items that it covers. So, we've already talked about assessing the impact of variations. If you do end up with increases in hard surface areas, are the new areas pervious or impervious, and does that affect the downstream part of the components and whether they've got sufficient capacity? Changes in levels is particularly important because in normal construction, particularly for landscaped areas, there's probably a much greater tolerance for variation in levels than there may be with SuDS. Because even along the swale, even a small drop below the design levels can result in water flowing where it's not intended. We've talked about substitution of proprietary products. Will they perform to the same standard? But the same also applies to plants and seed mixtures as well, which are very important. And value engineering, a very much misused word. In the UK, value engineering is not what it was intended to be, the way it's applied mostly. In the UK, it actually ends up being get the cheapest thing possible. Value engineering and value is actually looking at the benefits and costs. So if you value engineering something, you should actually be getting better performance as well as a reduced cost. So tolerances, again, the appropriate tolerances, and these mainly fall around paving levels and falls, materials, aggregates and geomembranes, and around porosity and infiltration results. And you can see there's a few cartoons in there to illustrate these points. So again, an example from the document is for surfaces, for permeable surfaces in British standard, on an interpave guidance I think this is from, but there are standard tolerances that we work to for normal block paving that we can start to use and adapt for permeable paving. And you can see there on the left hand side some suggested tolerances for pervious surfaces. We then go on to look at construction in difficult sites, and an example here is high groundwater. Again, you need the forward planning to plan on managing the groundwater using an appropriate scheme and managing water flows into the excavations. So both these examples on the right hand side just relate to controlling groundwater where we're installing plastic tanks. It is quite important. I've seen quite a lot of these tanks that are wrapped in membranes float away and move out of position. simply because there's either a very small amount of groundwater in the bottom of the excavation or simply from rainfall that falls down the sides of it. Difficult sites on contaminated land. Again, there's advice because quite often we're excavating SuDS features either into contaminated soil or potentially through a capping layer. So a common way of remediating contaminated land is to provide a capping layer over a clean capping layer of soil over the contaminated material. If that's already been placed in a public open space, for example, then we need to maintain the continuity of that when we construct the SuDS through it. Also, we need to take appropriate health and safety precautions if we're digging into contaminated material, for example.
Okay, so we're now moving on to soils. So this is really important to understand the different types of soils that are likely to be used on a site and for the SuDS and where to use them. So in terms of natural soils, there are two types that are commonly used. So what we call natural soils that will come within the guidance of the British Standard, which is what you'd use or could use on a site anywhere. And specialist soils under the British Standard are those which have got a particularly high or a particularly low pH. And those are things that are going to be used very much on specific projects for a particular reason. But generally, we will be trying to deal with natural soils. However, we all understand that natural soils are not always available, and therefore on many landscape sites, we're dealing with manufactured soils. Now, there's no problem with that, except for what I would suggest is that ideally you would not use manufactured soils within the SuDS, and you would not use them as part of a mix if you're trying to create things like bioretention or filter media. Do use them in the general landscape parts of the project, but we would suggest that you would avoid using those within the SuDS. Try to use natural soils in those. So bioretention or filter media is a mix, and that can either be mixed off-site or mixed on-site in small quantities. And there you're having to actually get the properties right with that, because the point of that is to actually have something that will drain down within a required time scale. Structural soils are those that can be compacted and therefore will allow you to construct paving over the top of them. And so again, that's a very specific requirement. And then engineered soils, we're back into, again, gravel and sand mixes with some soils that, again, are likely to have, will have plants growing in them. So it's very important that you understand how each of those is going to be produced, where you're going to use them, and if you've got several different types being used on site, that each of those types are kept separate and identified so that they're used in the right places. Because if you don't use the right type in the right place, you run the risk of either them not giving you the drainage that you might require, or that you're not allowing the plants to grow properly in the circumstance in which they've been designed for.
Another area where we see a lot of problems is with inlets and outlets, and Sue showed you a great example earlier on of how it can go drastically wrong. So it's important when we're constructing the inlets and outlets that we use the correct pipe sizes and that we provide the head walls, weirs and flow controls as they're shown on the design drawings. So the other issue that we should see is looking at visual, that the visual are maintainable and aesthetically pleasing. So just as an example, on the right hand side, the third slide down, the weir and that slot in the brick wall at the top is a flow control for the SuDS. Should have actually had a stainless steel plate in there with a design V-notch weir in it, which was omitted by the contractor. With geosynthetics and aggregates, again, all the different types of geomembranes, geotextiles, geocellular confinement, etc., it's important that the contractor understands exactly what needs to be used in which place and that they're installed correctly. So for aggregates in particular, where we're using aggregates in SuDS, they're normally being used to store and allow water to flow through them easily. So they generally, well, they are open graded. They don't have fines in them, and particularly sub-bases. The sub-base we use is quite different to type 1 sub-base, and you can see that in that picture on the bottom right-hand corner. And geomembranes, you should really be using specialist installers who can do the required welding, which you can see on the second picture down.
Okay, so that then brings us really to the section which is all about the different SuDS components and the issues that are likely to arise when you're constructing each of these. And we've just picked out a few of these to talk through, some of the more popular ones, to just give you a flavour for the way it's approached in the document.
So again, for permeable pavements, there are different types of surfacing which we've identified. So you can have reinforced grass, loose gravel, porous asphalt, as well as the commonly known permeable block paving. We've talked about using it as an access route during construction and coring it. You also need to look after it once it's been laid. So you can see on the right-hand side at the bottom that site materials have been allowed to spread onto a finished surface. One of the questions we had earlier, that was when I was talking about housing association sites needing the streetscape to be constructed. And the question was, can't the permeable paving for the housing association be the last phase of the construction process? It can be, and that's ideally what would happen. The problem is that the housing association will not accept ownership of the houses and will not allow people to move into them until the permeable paving is constructed. So what that could mean is that the houses are there and completed, but they can't have people living in them for 6 months until the site's finished. And obviously the developer wants the housing association to take them over and have people living in them, because that's maintaining his cash flow. So that's the reason why it's not appropriate in those situations. You can see up there on the top there's a picture of a site that I inspected where there was a complaint that the permeable block paving wasn't working properly. That's because it had all been constructed using normal block paving, except for the single permeable block that you can see highlighted in the red circle. At the bottom, of the second picture down, you can see that there's advice on how to compact and when to compact the permeable blocks. And some of the manufacturers, such as Marshall's, for example, have got very good videos showing you how to construct concrete block permeable paving. Okay, so bioretention systems. I think this is a really good chapter to get to grips with. First of all, what we've done is to actually explain the different types of bioretention systems, because the joy of bioretention systems is that they can be used in so many different ways, both in terms of new build and in terms of retrofitting. But the principles of their construction is pretty much similar throughout. Probably the main difference being that if you're disconnecting a downpipe on a retrofit scheme, then you're probably reconnecting it into the existing drainage system further down the line, whereas if you're constructing a new bioretention system, then you're just going to be connecting it into the main drainage system. Bearing in mind that obviously if you've got good infiltration, then you may not need those connections, but in the main we're looking at attenuation storage, so we are connecting into a drainage system at the end. I think this is something that people find slightly difficult to understand, because when you're looking at some of these systems, and particularly something like
something that looks essentially like a planted swale, is that it looks like it's a completely natural system, but in fact we've got all the filter media and we've got all the drainage happening underneath it. It's just not evident on the ground. So, and a good example in that first number one of where things have gone wrong, and that is because in that instance, although there was some bioretention filter media put into that bioretention system, it was left low, and that was obviously deliberate because that gave it some of its capacity, and the contractor found some very nice clayey soil that was looking quite good on site and thought he'd top it up, at which point no water could infiltrate through it whatsoever. And then again, looking at different sorts of issues arising whilst you're building these systems. So ensuring that you've got the right materials, the right build-up from the base all the way through to the top, the fact that you're setting the levels right for where you've got your weir walls to manage the flows down through the site, the fact that you've got systems in place that are allowing the scheme to overtop and drain down in the event of extreme events with that overflow system, that you've got the right plants in the right places to do the job that they need, and a very important thing of making sure that where you're using bioretention systems in highways, that you've got properly designed and well-designed systems in place to enable the water to flow through into your bioretention planter in the first place. So getting those details and levels right to get the flows through into the system, and then again hopefully you will have your silt traps in there to stop the system getting clogged. All of those details, which are really quite small in combination, are all important to ensure that the system will work properly once it's installed. And then in this instance, without going into the details, but one of these mini case studies here on bioretention systems, whereas what you can see is there that the soil in the bioretention system is actually higher than where the water's coming in from the inlet in the street. So that was an error there. It was all put in far too high, and so the water just collected around the inlet, and the whole lot had to be taken out and redone.
And the reason for that is that normal landscaping areas tend to be higher than the surrounding paved areas. So the contractor has just done what he would normally do without understanding the SuDS construction aspect. So with swales, sorry, a bit of confusion there about who's doing what. So swales, again, just some examples. There are different types of swales in the SuDS manual which are explained here. So sometimes we do put a filter media or a French drain below the level of the swale. And you can see some of the, again, just examples of swales that have not been constructed particularly well. So if you look at the top left-hand side, that there's a pebble channel is at a lower level than the swale. That's an inlet into the swale, but it's at a lower level. So water can't actually flow into the swale easily. And again, there are just various examples within the document that we've found, or that the members of the steering group have found. So essentially, we're allowing other people to learn from mistakes that have been made before, so we don't keep repeating these same mistakes, and we improve the quality of the construction. You can see there, again, an example on the top right-hand side. There's a sandy root zone in the bottom of the swale, which is there to allow some additional infiltration and filtration from a water quality perspective, and there's an underdrain underneath that. But it's important that the contractor understands that that material is different to the topsoil that he's putting on the sides of the swale. So the sandy root zone in the bottom needs to be free draining. And if he used the normal clay topsoil that he's put on the sides, the swale wouldn't perform in the way that the design intended.
Okay, so now moving on to trees, because obviously in the urban environment, this is one of the key areas where we can make a contribution, where other SuDS may not be acceptable. So I think one of the important things to do, because I think this whole issue of constructing trees in the urban environment with SuDS is quite tricky to understand and also to get everybody to engage with. So it was really important for us in the first instance to really try and pull out the key ways that you can actually construct trees with SuDS in the urban environment. So the important thing, so what we've done is we've got 4 examples here of the different types of SuDS and trees and how they can work. Because obviously what we've got to be able to do is to provide a stable surface on which paving can be constructed over the top. But some of the key elements there are ensuring that, one, that you can get air and moisture into the root system of the tree, to ensure that the base of whatever it is you're using as your medium is drained and therefore the water can get away, that you've got, and you don't compromise the square meterage of paving that's actually draining into any one tree pit, because you just can't drain an entire site necessarily to one tree pit. And then getting all of those elements together in the right way. Now, there are several ways that you can actually construct your SuDS using different media. So in the first instance, the fact that you've got a tree sand or an Amsterdam tree soil, something that is compactable, that you can actually plant your tree into. Then other ones, the second one down, where you can see what's called a structural soil. So this is where there's large areas of rock that are laid down, and then soil is washed into the interstices between those rocks, and then the tree itself is protected by a sort of concrete or other framed system, and that area is then filled with soil, and the tree is planted into that. But that the tree then roots down into those gaps in the rock, which can have been compacted to actually take the paved surface. Then other systems that you might look at, so those are crated systems, which are going to be filled with soil, but the crates themselves are providing the structural elements so that you can then do the actual paving construction on top of that. Or the final one where you've got a raft system that again enables you to get a stable surface but allow the space for the tree roots to actually develop in the below ground system. So these are very much issues where you need to really have got your capacity for your soil or your rooting area right, that you've got the right area that's draining into it, and that as I say, you've got the air and the moisture to support the tree, but that you've also got the drainage out to enable the SuDS to work properly. So these are quite complex systems to construct, and which type you choose will very much be determined by the nature of the ground that you're working in and the conditions there and what it is that you're trying to achieve. And so I think there's some good examples there of how to get these things right, and also some of the problems that can arise if you don't get all of these elements correct when you're doing it. So really, this is now coming to the end of our little presentation for you, and hopefully we've now got a little bit of time where we can look at some of the questions you've been sending in. But really, the point of this is, and I say to people, having been involved in writing this guidance, I think for me, it's very much changed my approach to design, because understanding how you need to construct these things absolutely does inform how you design them in the first place, which I think is a very important lesson to learn. But I think what this shows that this is really about team working, and I think to get it right on site, we have to communicate and we have to work with the team to get it to come together. And we very much hope that this will help people to overcome the problems that commonly occur, because at the end of the day, we need the SuDS to work, because we need the outcomes that they can deliver, and also to help prevent flooding and deliver good water management. So I think we're now going to look at a few questions.
Okay, there's a few. There's a few questions. One.
I've answered that one already.
Yeah, one that Steve has already answered, but there's one here from Claire Guthrie, and she's asking, is it possible to maintain permeable paving to maintain functionality, or does it have a finite lifespan? I'll start with Steve.
So, so just to repeat that, is it possible to maintain permeable paving to maintain its functionality? The answer is yes. There must be at least 50 technically reviewed papers that I've got that demonstrate that you can keep permeable paving working indefinitely. So it clogs at the surface. So when you get soot washing into it, the soot accumulates in the top 30 millimetres of the joints between the blocks, and we know that we can rehabilitate it using road sweepers. There are even companies in Scotland now, because they've used so much of it, that there are specialist small companies that have cropped up that go around with a transit van and a small handheld cleaner that they can use on permeable pavements. So it doesn't have it's got a finite, an infinite lifespan in terms of drainage performance. The other one, where can I download the SuDS guidance? There's a very good website called SuSdrain.org, www.susdrain.org, which is the Syria website for sustainable drainage. And there's a link on there to the SuDS construction guidance and the SuDS manual, and an awful lot of other invaluable information about SuDS design, construction, etc.
And then there's a final one from Amanda McDermott, who asks, has been advised that geotextiles eventually silt up and are unnecessary. What are your thoughts, please?
Again, it depends. If the geotextiles are being used correctly, they shouldn't silt up. So if you're using geotextiles to filter silt out of the runoff, they will eventually clog up. But they shouldn't be used in that way. Normally, they are being used to separate materials and stop a finer material being washed into a coarser material. And the two most common examples of that are where you place them in between the laying course for a block paving pavement and the underlying subbase. And if the overlying laying course, which is finer, can wash into the voids in the underlying subbase, you can put a geotextile there, but if you specify if you specify the grading of those two materials, you can actually specify them so that they are compatible, and the finer material will not wash into the underlying one. So you can remove the geotextile in that instance, and they're not necessary. There has been in the past a lot of claims that the geotextile is necessary to remove pollution. Well, we now know that that's not the case. The other instance is in bioretention systems, where you want to separate keep the filter material separate from the underlying drainage layer. Again, because normally you'll have a fine sandy type material on top of an open graded aggregate. And if water washes through, it can wash the sand into the aggregate and wash it away. A geotextile in that position, again, if it's specified so that it's appropriate for the grading of the materials above and below it, will not clog up. Because in a bioretention system, the silt will be trapped on the surface or in the top 20 millimetres of the sand material, so it never gets anywhere near the geotextile. And in that instance, you do need the geotextile, as I said, because otherwise the sand will wash into the drainage layer. You can actually put intermediate soil layers there that do the same function, but again, it probably makes the construction more difficult or more complex, certainly, than simply using a geotextile.
Right, we're just coming to the end of the presentation now. There are a couple more questions, maybe just for one last brief one. Vicky Chapman has asked, has consultation been undertaken with water authorities in the use of SuDS within adoptable networks?
Well,
big question.
That's slightly different to SuDS construction guidance. Yes is the answer in terms of what's currently happening at the moment. There is looking to be a revision to SuDS for Adoption 8, that will provide a pathway for enabling SuDS to be adopted by water companies. That's just the final draft is being written at the moment, and that will be going out for consultation quite soon. And I think there's hope that that will come in on stream as a working document in spring of next year. I've been involved in that, and that will be doing the rounds of the water companies, but there is a will in the water companies to actually do that as a whole. It's also quite likely that Ofwat will require water companies to adopt SuDS in due course during the next AMP period. So we are moving in that direction. And water companies are very much interested in ensuring that there is very good quality SuDS. And one of the things that will be key will be ensuring that the SuDS are built as designed, and that when they do adopt them, if and when they do, that they are going to ensure that those are fully functional and built as designed. So getting the construction right in that respect will be key to getting them adopted. So it's very important, that relationship.
Okay, thank you both, Steve and Sue, for that really informative webinar. Just a few final notes on today. Thanks everyone for participating. I hope you found it informative and enjoyable webinar. We'll be following up with a post-event short survey, so if you'd like to continue this kind of way of learning over lunchtime, then we'd be very happy to hear from you. In the meantime, once again, a huge thank you to Sue Illman and Steve Wilson. And there's a little reminder here that we are looking for entries for the Sustrain SuDS Awards. We are looking for case studies to be submitted by the 30th of March. So if you've got any good SuDS schemes that you'd like to submit and to have them scrutinised, and hopefully potentially be winners for this inaugural year of the Sustrain SuDS Awards, then please do send them through to us. And also a reminder, do try and take our Sustrain survey, which looks at overall the annual feedback on Sustrain, our website for SuDS, and how SuDS are progressing over the past year. So once again, thank you all very much for participating, and we'll hopefully see you all again soon. Bye.